She's the CEO and co-founder of Suede, a software platform that enables financial institutions to fully understand and deliver on their regulatory requirements. Prior to Suede, she had a successful career in investment banking with Barclays and Merrill Lynch.
We're going to have 2 sessions. The first one is going to be with Dr. Goh, an absolute legend in the field. Just to name a few of his achievements, he was named as top CTO by InfoWorld. He brought intelligence with NASA to the International Space Station, and he worked for 2 decades with Stephen Hawking. Not least Stephen Hawking. It's really incredible to have him here. And I think that what we're really trying to achieve is to understand, really get a really idea around the future of the financial landscape when it comes to AI and machine learning, and fundamentally understand what the competitive pressures are going to be coming around that.
Do not be swayed by deep learning, because deep learning is where the internet companies of the world have invested billions of dollars to get it right, because they do image classification very well. But that's not the only way. Keep that in mind. There is the random forest way, where you don't have enough data. There is the support vector machine, where your data has lots of columns that deep learning doesn't do well in. And there is naive Bayes, which we use for probabilities, important in the financial industry. Probabilities. Take, for example, you are in a racehorse. You bought a ticket for this horse. The race has started. Halfway through the race, your horse is number 2, and someone taps you on your shoulder and wants to buy your ticket. And it starts to rain. How much do you sell the ticket for? Right? So these are the kinds of questions, right, that naive Bayes can handle, that deep learning cannot. So people use combinations of these. Right? Let's look at examples of deep learning. The world got together and say, in order to learn from examples, let's all come together, collect 14 million images, and got the world to come in and compete who can classify those images well. Who can classify best? In 2010, 2011, they were using rules, not deep learning. Those rules could recognize paintbrushes very well here, not there. They got confused. Humans were better. Those rules were very good at recognizing sunflowers here, not there. They got confused. Humans were better. And then the world came in and said, let's switch to deep learning and leverage the fact that these images are labeled and train the machine through a labeling process. Just like in grade school. Pictures of elephant with a label below elephant. Right? 14 million of it, and eventually by 2017 exceeded 5%, which is brain, B for brain. Right? So image classification under those 1,000 categories, machine does better than humans. Those neural networks are better. It's done now. Why? $2 billion invested. Images. That's not all. There is voice. This is another big area. Very, very similar, using deep learning, recognizing patterns. First, you transcribe from voice to text. Then you translate. The voice to text required 100 million words to train well. And the text to text in translating a language, for Chinese, especially to English, they needed 1 billion words. So the message here is lots of data, good quality data. Right? And recently, Microsoft announced that for Chinese to English translation, just recently, they have matched professional translators. Yeah? But they needed 1 billion words. Yeah? Heidi and Jennifer are my handlers, right, in marketing. They always tell me not to do a live demo, but I'm going to do it anyway. I'll pick something not on this list, French. Yeah? So this is the Microsoft Translator. Right? I took a cab to the airport and got an earlier flight.
J'ai pris un taxi à l'aéroport et j'ai vu un vol plus tôt.
How was it? Yeah, it was. You see, there are 2 things about this. The translation, the transcription is almost immediate, and then the translation is pretty good, right? And the accent is also okay, huh? Yeah, right. But for Chinese to English, 1 billion words, right? Something. I wonder where they got 1 billion examples from, right? Good quality. Well, I learned something. They went to the UN. They have lots of these translators, right? Yeah. So lots of data to do this well. In our banks, don't forget you have call centers. You have asked for permission to record those conversations. GDPR, of course, must be adhered to. If you anonymize it and remove sensitive information, you can transcribe and translate, and get a sentiment of your customers. For now, all that data recording is sitting unused, right? So think about it. So in summary, the thing I have learned is to prepare for the future. Most important of all, other than understanding the fact that AI will permeate everything, just treat it like usual. Don't treat it as separate. And the fact that you have to keep your domain scientists. Other than those two, focus on data, because it is data that will decide how smart your machines will be in the future. So don't throw it away. But no point having hoarded all your data and not curated it. Curate it. I have seen CIOs who were the fifth CIO of the company, and then ask them for 20-year-old data. They say, I don't know, right? I'm the fifth CIO. I do not know what the first or second CIO did, right? So you have to start curation of your data right now. So quantity, quality. And then Heike mentioned, your data likely will be siloed. Either siloed because of regulation reasons or siloed because of geography. Federated. Because once you siloed and train a machine with siloed data, you'll only be as smart with blinders on. Now let's look at going forward, broadening AI. Big data, then we applied analytics. That was a few years ago, right? Analytics is really when you have a person, an analyst, in the loop, constantly working the system to uncover insights. Then came machine learning to help offload the analyst and allow the analyst to come out of the loop to let the machine do at least the first pass discovery. But making sure you filter false positives, or else you come back to the same problem, right? And then a machine learns to be artificially intelligent. In this context, we know that going forward, we need the machine to do more than just being narrowly intelligent. We want it to be able to handle constantly changing scenarios. That is, we want it to have some strategy. Not just a hardwired neural network to make a prediction, but also to be adaptive depending on situation. And then finally, autonomy. If a system is intelligent and you give it the ability to act, it becomes autonomous, just like an autonomous car. So intelligence with the ability to act. This will become more and more important in the IoT world, where imagine you have 1 million cameras going out there, you have 100,000 temperature sensors out there, millions and millions of devices that have to be smart. You cannot afford to take back 1 million HD video streams back to your data center, to your cloud. You can't do that. You need a machine to be smart out there. You will start to see this change coming, and it will influence the banking industry also. Google came up with federated learning so that you keep the data private, as Heike said, right? Each device have their own private data. They don't have to send it back, like in the first case, to the cloud. Just do the training themselves and send back the smarts backwards. We are developing another way, and that is totally do away with a central control. The million IoT cameras out there will talk amongst themselves and become smarter, independent of us. And how do you coordinate without a central authority? Notice the word central authority? We will be using blockchain. Because a centralized authority is where your data center is. If you don't have a data center, a central ledger. You have to use a distributed way, and that's the reason why blockchain is used. Although the public blockchain has too low a transaction rate, we're going to use a private one that has a much higher transaction rate for the million of IoT cameras training amongst themselves and teaching each other without us. Yeah? Of course, we want to have an off switch, yeah, right, for all of that. And then finally, don't forget there is the directed acyclic graph. There's an alternative to it. So don't be locked into blockchain or public blockchain like Bitcoin is, right? There are the two colored ones that in smart contracts, in this case, it's a smart contract among them, right? That we will need to use for higher transaction rates. Yeah.
So it's been really incredible. You really run us through everything that is possible. For us, it's been quite interesting because we do a lot of work in data, and that's enabled a lot of our customers in financial industry to do machine learning, which, as we were mentioning, is really a branch, I guess, of AI and of what is possible. A question that I have for you, when you look at the whole world and the industries that you observe, how do you think we're doing in financial services? Are we behind?
It varies with which part of the financial services world are you talking about. The people who are doing trading are ahead, right? I've seen them. The reason I know is because we have supplied systems from the early days of high-frequency trading, and then we get the stock exchanges coming back to us to build system to cope with the high-frequency traders, right? We've been involved with quants, right? And in fact, these quants who write these Black-Scholes equations and variations of them are physicists. That's why they say they hire rocket scientists in there. So those groups are well in advance.
Yeah.
But then you've got retail banking, and you've got, some parts of investment banking, insurance, right, that are now getting onto this bandwagon in a serious way.
What's interesting when you look at everything that's done in the industry around, AI and trying to teach machines to do better with the data, right now it is really a cost center, right? So for most financial institutions, when they're trying to do this kind of work, they see it as R&D that's very expensive.
Yes.
So how do we turn that into profit?
Yeah. I think the analogy I would like to draw is that think back of the early days where the financial industry or the banks weren't computerized. You actually had a centralized ledger called a logbook, right? And then computers came. It wasn't treated eventually by today not as something alien. It is treated as something necessary that permeates everything we do. Think of AI as this next phase, where everything you do can leverage the fact that you have historical data so that you can make better decisions or augment your domain expert decisions. Treat it as something that will permeate.
They are saying that 60 million jobs will be created thanks to AI. So what are your views around that effectively?
Yeah, jobs, big concern. Near term, what comes up first is what do we do about jobs, right? Long term, we talk about the correct and right answers, right? Yeah, right decisions, right? Jobs. When I was at Ford, this example was used, right? Not particularly Ford, but I was there in Dearborn, Michigan, Detroit, Michigan. And, in the old days before robots came along, they were producing 1,000 cars a week and hired a bunch of people to do that. And then when robots came along, they were producing 100,000 cars a week, hiring more people, right? So I think the key has to be, one of the answers has to be increased productivity so that the world population can benefit from these gains. In this case, cheaper cars, right? So there's something to learn from there, right? And it's always augmentation. In the first 10 years, it'll be augmentation. Yeah, I've heard how we can assist a strategist, right? Formula One car racing, it's a very popular one. I just came from Austin, right? The race was there before. And when do you pit stop? It's a tough decision, even though it's only 2 seconds to swap your tires. But in that 2 seconds, someone could overtake you. So should you pit stop for this track that is difficult to overtake and it's raining, right? So these are kind of things that strategists advise the driver over the microphone too. But these strategies are now augmented with a machine. You won't let the machine take over advising the driver. Yeah, at least in the next 10 years, I see. It will be an augmentation.
That's wonderful.
Yeah.
Thank you so much for that. Everyone, please join me to say thank you to Dr. Goh and for all the insights.